Good evening together. My name is Jonathan. I represent Technik today. My colleague Maxime Rallic is ill. I got this information yesterday, so I will take his part and give you all the informations. 2 years ago, my colleague Gerald Erler introduced here at the Heat Pump Summit our closed loop design. I would like to pick up this point today, and I will give you first an overview of this closed loop design we are using at our heat pump test benches. We are using an insulated chamber, but without any air condition units inside. Only the heat pump, our test on the device, is placed inside, and we have air distribution plates from a uniform air distribution inside the chamber. Maybe it's... Yes, we will see here. Using one closed loop chamber, it is possible to test heat pumps, which are set up and outside of a house like shown in the picture. But as you know, as professionals in the heat pump branch, the variety of the heat pumps and ventilation systems are much bigger than more diversified. We have heat pumps outside, inside units, and splitted uses. So the systems are getting more and more complex and diversified, and it means that also the requirements on the test equipment are more challenging. To be able to realistically simulate the ambient condition of the heat pump with a combined ventilation device on a test, a single chamber is not long enough. It would only simulate, as shown here, the outside area, the inside area, and the installation room. In this picture we see a rough technical scheme of those three individual test chambers representing the three areas: living room, installation room and outside room in one test bench. We will have a closer look to the setup that we have already realized at a customer project. There we will focus on each individual of the three chambers and their specific requirements. But before getting into these details, I'd like to show you which kind of heat pumps and air conditioning units can be tested in this test setup. Possible devices under test are central ventilation units with a heat recovery, decentralized ventilation units with and without a heat recovery, air and only exhaust air on only support air, combination devices of heat pump, ventilation storage tanks, heat pumps with an external unit. So you can already see that it is really possible to test a wide variant of heat pumps and air ventilation units in one test bench. The living room chamber. We will have a closer look to the three chambers and the technical relation now. We will start with the smallest chamber, the living room chamber. The air is moved in a closed loop via a radial blower. We have air distribution plates and the inlet and outlet side of the chamber for uniform airflow. The temperature regulation units and the humidity regulation are outside the chamber. The pre-conditioned air is supplied in the living room chamber. DOTs that must be installed in the living room chamber are not so big. only parts of the ventilation units, there's decentral ventilation units. Therefore, the chamber is in the smallest of the three chambers. Installation room chamber. The installation room chamber is realized with the standard climatic chamber, as the preconditionated air in this test room has already hardly impact on the test produces for different devices on the test. So the installation room chamber has a rather simple test setup. The installation room chamber is big enough for installation of devices on the test. The setup could be flexible for different kind of devices on the test, as it has different connection possibilities to the outer chamber and the living room chamber. The outside chamber. The outside chamber is the most sophisticated one in these test benches. Temperatures conditioners must be very uniformed for accurate, as the conditioners here we have a big impact of devices on the tests. We have air distribution plates on the inlet and on the outlet side of the chamber in the uniform airflow. The temperature regulation units and humidity regulation are outside the chamber. The preconditional air is supplied to the outside chamber. The challenging point here, which makes the condition much more sophisticated than the living room chamber, is that the effect temperature conditioner should go down temperature of minus 20%, 20 degrees. At duration tests at the minus temperatures. This might lead to problems during longer test periods. When you want to make endurance tests at minus temperatures, even down to minus 20 degrees, you will face the problem of freezing at the heat exchanger. Therefore, it must be possible to defrost the heat exchanger, which is realized here with an additional heater. Those two heater exchanger systems are running alternately there, and therefore assured as continuous operation without interruption, also allow temperatures down to minus 20 degrees. Humidity conditioning at lower temperatures. With the humidity conditioning of the air, humidity can be introduced into the air in the loop, or humidity can be removed from the air into the loop. An absorption dryer is proved to dry the air in the outside chamber, so to remove humidity. The introduction of the humidity is done via a stream ring pipe. Introducing the humidity is particularly important in the outside of the chamber. The heat pump is acting in this chamber as the humidity consumer. The heat pump as the test objects are distributions available in the concentric circle of the test chamber. Sorry. Okay, next. At the beginning of the presentation, we had a look at the technical scheme of the three chambers, the test benches. We have looked at them. Sorry, we have looked at them now at the details. So here I can show you now a customer project that we have already realized with this test setup. I've marked here the photo, the three chambers with the colored code. The small living room chamber at the first floor, the simple installation room chamber at the ground floor, and the direct connection, the sophisticated outside chamber. The conditioners of units of the chambers are placed at the first floor, above the tooth chamber. As you can see, in comparison to my colleagues, the test benches are rather big dimensions and a kind of the layout. You can see this is the colleagues, this is the test chamber. Here I'd like to give you an overview of the benefits of the test benches and outlook on what we really have in our project pipeline. Heat pump test benches are variable at the number of the test benches, living room, installation room, and outside. Excellent temperature and humidity conditioning, closed loop design, able to test heat pump that work with a low GWP refrigerants, ATEX Zone 2 security concept. Outlook integration of acoustic measurements, A2 acoustic room for development, integration of CO2 and VOC conditioning for optimum test and demand-driven ventilation system, scale up to the relation heat pump test bench for large heat pump test to 250 kilowatts. Finally, I would like to introduce short the company Erler Prüftechnik Engineering. If you are here new to us, it may be because we are not specialists at the heat pump technology, but EPE is specialist in individual testing, engineering for high precision gas flow meters and conditioning. We have realized more than 3,500 projects. Sorry. High application competence in conditioning of air and expertise in test branches for X area. High precision flow measurements. This is the calibration pyramid we show here. Yes, the device on the test over the working standard for industrial laboratories, the second standard of calibration labors, and finally the primary standards using by National Meteorological Institute, which must be traced, the SE unit. And this is the wrong way I explained it. This is the first one, and this is the primary standard. So, okay. So we finished. I thank you for your attention. I hope I give you every information from my colleague. So do you have any questions? It's no problem, write us an email. My colleague, Mr. Rallic, will answer everything you want to know about it. So thank you very much.